Hello and welcome. Today we're going to be looking at a TMUA past problem. This is from 2023. It's paper 1, question 20. And I recently went over this with one of my students. They found it quite difficult because it's a little bit of an unusual problem. We're asked to optimize this function, but we don't know exactly what the function is. And we're used to knowing what the function is so that we can, so that we can differentiate it and look at the stationary points, which is not as much of an option here. So let's dive right in and see how we're going to circumnavigate that and get to the solution to this problem. So the setup is we're given this graph of function f of x, and we're told its maximum minimum values. The maximum is at a coordinate of 1, 2, and the minimum is at a coordinate of -1, -2. And we're now asked to find the difference between the maximum and minimum values of f of x squared minus f of x. We can look at the potential solutions that they give us. I have to say, they're not super exciting. They do look like they're maybe around the right size, but there's quite a lot of variance in the options, and perhaps we'll be able to eliminate some of them later. But it seems like that might not really be the way forward. Another thing to notice is that we're asked specifically to find the difference between the maximum and minimum values of this function f of x squared minus f of x. So we maybe want to give some thought to this word difference. Is it important? Is there a way to find specifically the difference? We can, of course, find the maximum and minimum values themselves, but maybe there's a clever way to get to the difference specifically. I've thought about it for a moment, and I think most people, after thinking about it for a while, will sort of come to the conclusion that the easiest way forward is going to be to just find the maximum and minimum values themselves. So how are we going to do that? I've mentioned that we don't know what f of x is, and that's a little bit of a problem. Now, something we can notice is that this expression over here, f of x squared minus f of x, is a function of f of x itself. So if g of x is x squared minus x, then f of x squared minus f of x is going to be g of x. Usually when we maximize or minimize a function, we try to find the value of x, which leads to maximum or minimum. However, that's mostly hopeless here because we don't know what f of x is. So we don't know what a specific value of x is going to give us, other than these 2 points over here. However, now that we know what we want to optimize is a function of f of x, we can try to maybe find the values of f of x which maximize or minimize the function. And in fact, we know exactly what values f of x can take. So we're told that the maximum and minimum are 2 and -2 respectively. So the function stays between these points. And we can also see visually that it takes every value in this range, but no values outside of it. So what that means is instead of maximizing over x, we can try to maximize over f. So the maximum we're looking for is going to be the maximum of f squared minus f in the range -2 to 2. And similarly for the minimum. I'll just write that down. At this point, the question is hopefully looking a little bit easier. If we stop and think for a moment, maybe the f is obscuring this a little bit and it's harder to spot, but this is just a quadratic in f. So all we need to do is maximize or minimize a quadratic, and that is something that we hopefully know how to do. Now, I'd always recommend doing at least a small sketch so that we don't make any mistakes. And so we'll start off by completing the square. This is going to be f minus a half squared minus a quarter. And we can also read off the roots. This is f times f minus 1. So the roots are at 0 and 1. To start our sketch, we mark on these points. So we've got a root at 0 and 1. The x-coordinate of the turning point is going to be a half. So that's right between the roots. And the y-coordinate is going to be minus a quarter. And mark that on. And we shouldn't forget, of course, that we are sketching within a boundary. So we're sketching between -2 and 2. Finally, this is a positive quadratic. So we have something like a U shape, and every quadratic is symmetric around its turning point. We can finally sketch that in. Now you can see straight away that we have our minimum over here. The minimum of the quadratic itself is the turning point, and that turning point is within the range. So it's certainly the minimum within this range, and that is minus a quarter. When it comes to the maximum, we can see that our quadratic increases as we move in either direction away from the turning point. And that means that the largest increases within this range are going to be at the boundaries. So our maximum is going to have an x-coordinate, or I guess in this case, an f-coordinate of either -2 or 2. When it comes to which one of those it is, you can see visually that it's going to be -2. How could we justify this? Well, quadratics, like I mentioned, are symmetric around their turning points. And over here, you can see we've moved 3 halves to the right, but we've traveled a greater distance to the left to get to the boundary of about 5/2. And so that's going to yield a larger increase. So this means that our maximum is going to have the f-coordinate -2. And so it will be -2 squared minus -2, and that comes out to 6. So the difference is going to be 6 plus a quarter, and that means that our final answer is 25/4, which is option F. Thank you so much for watching. I'll catch you all in the next one, and until then, good luck.